Hi, this is Matt, and in this video we're going to talk about vectors. We'll explore the definition of a vector, look at addition and subtraction of vectors in terms of geometry, and then different ways in which we can represent vectors through mathematical notation. So, a vector is a quantity having both a direction and a magnitude. Let's consider an example. Let's say I arrive at Buda Airport and I want to make it to the university. Well, the vector that's 10 kilometers long in the northeast direction would describe that journey. So it's 10 kilometers, so the magnitude, if I go 100 or a single kilometer, well, that doesn't get me there. So that's the magnitude component. And the direction heading in the northeast, well, if I were to head south or east, I'd wind up in the Norwegian Sea, and that wouldn't be good. So the vector has both the direction and the magnitude. If we look at some examples from physics and engineering, vectors are often used to denote velocity, momentum, force, electromagnetic fields, and weight. These have both a magnitude component and a direction in which the force or the velocity is headed. Now, if there aren't a directional component, often these are referred to as scalars. So speed, for instance, if I'm going 30 kilometers an hour, that's just a quantity and doesn't tell you where I'm going. Mass, electrical resistance, hard drive storage, population, these are all just numbers and not vectors. If we look at how we denote vectors, well, I could consider the example where I start at the point O, my origin, and I get to the point P. Well, that vector from O to P is denoted by either V in the boldface or OP with this arrow and a little dash on it. So that's the vector OP. Now I can scale this vector accordingly. So if I were to look at twice the vector V, well, that would be a vector in the same direction but twice as long. And if I look at half of V, well, you'll notice that it's smaller, it's shrunk. So if I multiply or I scale my vector by anything less than 1, well, that'll shrink it. And if it's larger than 1, that'll make it longer. And if I multiply by a negative scalar, so if I make it negative v, well, that's now the vector PO. It reverses the orientation. So the direction in which it's going is now reversed. Vectors have a magnitude component as well as the direction. So if we want to talk about the magnitude component of v, or its length, you'll see it referred to as either single bars or these double vertical bars around the vector. This just signifies the length or the magnitude. And there's special cases. So if the length of the vector is 1, it's referred to as the unit vector. It's 1 unit length. And if the vector length is 0, which seems kind of odd, that refers to the null vector. I've gone from point P to point P. I haven't gone anywhere. Now, vectors come in handy when we talk about force or we talk about competing things working together. And so what we'll look at is, well, what happens if we add two vectors together? Let's say I want to go the vector v and then I want to go the direction u. Well, we have a method for doing this called the head-to-tail method for adding vectors. And so you'll see that geometrically I can add two vectors through this method and I get what's called the resultant vector. So first I lay down the vector v, and I align the vector u such that the head of the vector v, so the arrow, the tail of the previous vector lines up with it. And what you're left with then from the start to the finish is that resultant vector v plus u. And since addition is commutative, well, I can look at going u first, so I go the direction u, I align the vector v up, and that resultant vector is now u plus v. Notice they look identical. They're the same length and the same direction. Subtraction of vectors works very similarly, except for subtraction is not commutative. So what we have to look at is the same process, but let's say I have my vector v, and I want to look at subtracting u. Well, I look at negative u, v minus u, so that direction is reversed. You'll notice here that now we lay u going negative, going this direction. And then the resultant vector is v minus u. Again, I could look at u, I could look at then a negative v, and that resultant vector is now u minus v. So that's geometrically how we can add or subtract vectors. Oftentimes we're going to want to put vectors on the coordinate plane or an R2 so that we know where we're starting and where we're ending. So let's say I have the coordinate plane here, we have the x-axis, and we have the y-axis, and I look at the coordinate point 3, 4. Well, we denote this point with parentheses, 3, 4. We're familiar with it. But now, what happens if I want to denote the vector v from the origin to that point? Well, I can do this in several ways. One is using the brackets 3, 4. So these little brackets here denote the vector from the origin to the point 3, 4 versus just the point. Another way to do it is what we refer to as using the standard bases. And what these are unit vectors along both the x and the y axes. So this I down here is a unit vector, so it's of length 1, and this I hat's just what we refer to the little denotation of it, is the unit vector along the x-axis. And the j vector, j hat, is the unit vector along the y-axis. And so what we can see now is that v is denoted by 3i plus 4j. So that we scale the vector I 3 times, and then we add 4 of the j vectors. So where we get that from? Well, 1, 2, 3 I vectors. 1, 2, 3, 4. 4 of those j vectors will get me my vector v. We can also look at the magnitude of v. So if we look at the magnitude of v, we use the Pythagorean theorem, and we see that, well, it's of length 5. So that's how we can talk about vectors in terms of the coordinate plane. Another way to do it is in terms of polar coordinates. So let's say I have my x and my y axes, but instead of looking at a grid, I can still look at that same point, 3, 4, and the vector v trying to get there. But instead what I'll look at is I want to look at the length of v and the angle that it makes with this positive x-axis. So again, the length, which we'll refer to as r, so here's the length r, and theta, which is the angle that it's making, that vector, the angle that it makes between that and the positive x-axis. So in this case, we have r comma theta now denotes our new vector v. And so for this vector in particular, it's 5 comma 53 degrees. And how we get that 53 degrees is through trigonometry, which we'll explore in some later videos. So here's another example in which we can represent vectors. Instead of the coordinate plane, we'll look at polar coordinates. Special thanks to our sponsors for helping us produce these videos. See you again.